Okay, welcome back to the DIY aquarium controller build. This is about float switches, adding float switches to the Raspberry Pi and then adding them in the Reef Pi controller software. So quickly we're just going to go over the hardware needed to get this done. The way I've done it is I'm using just your traditional float switches as shown in the other videos. They have a extension cable coming off of them because usually when you buy them they only give you about 12 inches of cable coming off the switch. And this is the circuit here. You can pause the video or whatever and you can see the circuit. But essentially I've got the ground wires going to a ground rail that I created in a little connection box, again, which I've shown. And that's because the GPIO pinout, this pinout section of the Raspberry Pi only has a few grounds, and so I just wanted to make more. And then the other wire comes to one of the GPIO pins. I suggest when you're putting this together you pick your pins because we're going to need the number of the pins that we're connecting them to for some scripting in the Raspberry Pi. And the reason why we need that number to make a script is because these float switches need what's called a pull-up resistor to get the appropriate proper signal for them to be read in the Raspberry Pi, and therefore them to be read in the Reef Pi software. Now, a pull-up resistor, there's a couple of ways you can do it. You could actually wire a pull-up resistor in line with the float switches. Essentially, what you have to do that way is you got to run, let me show you here quickly. You'll have to run one wire from a 3.3 volt connection to the one wire on the float switch, and then you're going to need usually around a 10K resistor between that wire and the wire that comes to one of the other pins. Now that's a little complicated and annoying, and I just don't want to do it that way, so I'm going to use the actual onboard resistors on the Raspberry Pi, and I'll show you how we do that. So first, before we do that, here's the circuit. This is how it works, and then I'll just quickly now show you it in real life, what I did to build the float switch and how I'm connecting it to the GPIO pin there.
So looking at the actual hardware of the float switch, all I have is just the regular cheapy float switch, and the wires, they actually come up here, and then right about here they are soldered onto some 22 gauge wire, and they each have shrink wrap on their connections. And then there's about 5 feet of that 22 gauge wire that comes up here, and that's soldered onto basically what I did is I took one of these DuPont connectors, snipped it in half, and then stripped the ends, and one half is on here and one half is on there, and the brown one on this example connects to the ground, and then the blue one connects to one of my assigned float switch pins. And then what I did, just to make things a little easier and cleaner in terms of wiring management, is I shrink wrap the entire 5 foot lengths of the two wires just to keep them together and nice and neat for cable management. You can actually do something better than that if you have. You can just get a single wire that has 2 conductors and then solder the conductors, the 2 wires to the 2 wires from the float switch, so you don't have to do a giant shrink wrap of the length of wire. It's just because these float switches only usually come with like 12 inches, and often you need usually about 3 to 5 feet of wire to have some good cable management. So yeah, back to the computer once. Oh, and then just so you know, I lost the sheath for that header, so I'm just gonna have to find one and put it back on there. But yeah, let's go back.